First, I'd just like to thank Michael and the other members of the ASC, whoever reviewed my proposal, for actually allowing me to be here, and also the young gentleman working the audio visuals for setting this up so that I didn't have to lug my own computer from California. My name's Lance Nizami. Everybody hear me adequately? I hope so. Good. I'm going to talk about a case in which resilience has gone a little too far. I call this when resilience trumps reality, what quantity from a second-order cybernetics perspective is inferred in infant psychophysics. I'm going to go over infant psychophysics very quickly to give you some idea what I'm talking about. I thought I'd mention Trump in the first slide so that we could get the politics over with right now and move on to the science. So, the gist of infant psychophysics, it's exactly what it sounds like. It's not youthful psychophysics, it's the psychophysics of youth, and that is we're doing measurements with babies. So you have an auditory trial in which you're giving sounds to infants, and then I'll show you some pictures of these things so you have some idea what's going on. And an assistant holds an infant. This is typically someone 6 months or less of age, the infant, for exposure to sounds, as you call them. I call them auditory stimuli, and a hidden watcher records the infant's behavior. And I'll show you very quickly how the second-order cybernetics comes into this. And an analyst, who is separate from the observer or watcher, constructs a psychometric function or some other quantifier of how well the infant detects or discriminates a sound, detecting a sound from no sound or discriminating one sound from another. Okay? And the question is exactly who or what is actually being quantified from a cybernetics perspective. And this is not something you're going to find in the auditory science literature. There was a beginning to this, as there always is, and that was a gentleman named Fentz in the 1960s who tested the visual capabilities of infants by having a watcher, whom we call the observer, record how long and how often an infant fixated each of two alternatives, and that was called preferential looking. So here is Davida, yes?
So at this time, is this the beginning of when they began to use the camera on the eyeball to see what the actual...
Okay, that I will get to.
Okay,
that I will get
okay,
to,
so this is relevant, okay.
Visual tracking and so on.
Pre-doing that?
Yes,
Yeah,
yes.
okay.
I'll get to that. Now here's a picture of a person identified as D.Y. Teller, Davida Teller, who invented the modern method following the work of Fentz in the two papers published in 74 and 79. And here's just a very simple illustration of a baby being held in front of two things: a visual grating, as it's called, which is a black and white stripe pattern, and a gray patch, which are matched for luminance. And what does the baby look at? If the baby looks preferentially at the striped pattern, it's assumed to tell the difference between a striped pattern and a plain gray square. And this is called preferential looking. Okay, this is a very informal description of how it actually happens. How does it actually happen according to Fentz? Well, this is looking into the apparatus. You lay the baby down, you slide it on a slide underneath a dark desk, and it has stimuli to the left and the right, which can be moved up and down a set of dowels, which are those angular projections to get it closer or further away from the baby. And directly at the top, you find a peephole. And the observer or watcher looks through the peephole and actually sees if the image, plain gray color or the striped pattern, appears on the baby's cornea. And that is considered a hit, and the baby's considered to be fixating on that particular thing. If the baby looks at that striped pattern longer than the plain gray background, that's called preferential looking, and it's assumed that the baby can tell the difference, and that's considered a detection threshold. And then you vary how far apart the stripes are to see what the baby will look at for a longer time and what they won't, and you can assume they're differentiating one from the other. So here's the actual, a very bad picture, but this was the best I could find from one of Fentz's papers. So this is actually scanned from a paper published in the 60s, and here's the little tyke being slid on this little enclosure underneath the desk, and in the background of the white coat you can see the watcher actually looking through the peephole, seeing what the baby is actually fixating on what they're gazing at. And again, if they gaze at a stripe pattern longer than a gray background, it's assumed that they can perceive the difference. And that's called preferential looking. Now, this was adapted by Werner and others in the 1980s after the work of Teller in the 1970s, and I'll get back to Teller in just a moment. And this is how the hearing experiments are done. You have a soundproof chamber. Outside that chamber, not hearing what is presented, is the watcher or observer. They do not hear what is presented. Inside, you have a table, you've got some toys, and you've got an assistant. And the assistant gets the attention of the child, which is shown here separate from the parent, but actually sits on the mother's lap typically, or in a chest pouch held by someone standing. And the assistant gains the infant's attention by waving toys at it until they decide, in collusion with the observer, using little lighted signals from outside the booth, whether the baby is paying attention. Then the observer will initiate a sound. Now, in some experiments, you'll have a speaker to the left and the right in front of the baby, and they'll look at whether the baby turns his head toward the sound. But it turns out that head movement is not terribly reliable for infants 6 months of age or less. So what they do is they take a single ear insert and tape it to the side of the baby's head, typically the right ear, after doing a proper examination of the ear canal to make sure it's nice and clear. And the baby sits there with a microphone essentially taped into their ear, waiting for something to happen. And when the baby is deemed to be sufficiently attentive, the observer, who can't hear the actual stimuli, will actually press a button initiating the trials. So here's the test environment. You're sitting at a table in a sound double-walled soundproof chamber, so the ambient level inside is simply whatever noise the people inside the booth is making. Otherwise, it's about 0 decibels, very, very quiet. And there's an observer sitting outside the booth, who I call the watcher, and activating the computer to present the stimuli at particular times. So what's the actual method? Infant sits on the parent's lap, listens to sounds presented monoraurally over lightweight earphones. It doesn't tug on the baby's ear. Infant's attention is manipulated towards the midline by an assistant. At certain times, the signal is presented, which is a tone, a white noise, shh, something of that nature. And if the infant responds in such a way that the observer from outside the booth correctly decides that the signal was presented, a mechanical toy, which is hidden from the infant's view, becomes available to the infant, and usually it's a little doggy that starts walking, or one of the little apes with a bellboy's hat that slaps cymbals together or something to reward the infant for having done the right thing. So that little toy appears and reinforces whatever response was made by the infant. So the parent and the toy waver are kept deaf to the presentation of sound because you don't want any body cues from other human beings inside the booth. So this is what's happening. Okay, here you see the infant, baby type, or small human being distracted by the toy waver to get its attention, because otherwise they cry and they fuss and they wet their diaper and they look at the mother and so on and so forth. It's found from experience you have to have the mother in the booth, sitting there with the baby. And at a proper time, the observer outside the booth presses a button presenting the sound, or not presenting the sound. It's typically either a 2-interval choice in which the sound is in one interval, first or second, and the observer has to guess based on the baby's behavior what interval sound was presented in, or in the typical modern experiment, a single interval in which the sound appears or does not appear, but the observer does not know which. And the observer looks through the window, watches the baby, and based on the baby's physical behavior, decides whether the sound was actually presented in that interval or not. So the observer or watcher is outside watching the baby. And if the sound was presented and the observer says, yes, the sound was presented, then the baby receives the reinforcement of seeing the mechanical toy appear. Okay, the baby receives the reinforcement of seeing the mechanical toy. Now, feedback is very important in cybernetics. If the observer is correct that the sound did appear, The observer is also told by means of a red or green light whether the sound had been presented. So the watcher who is watching the baby is also reinforced, and this is a form of so-called operant conditioning. What do the data look like? At the bottom you have adult thresholds. And as you can see, we hear best around 2 kilohertz. 2 to 3 kilohertz corresponds roughly to the sound of a baby's cry. So ecologically, we're primed to hear crying babies. So if you happen to find crying babies extremely annoying, as I tend to do, there's a reason for that, and that is you're very sensitive to the sound of crying babies. And the data that's been gathered suggests as the baby gets younger and younger, this detection curve essentially shifts upwards. So, again, the sound is or is not presented in a given interval. An observer must watch the baby and decide based on the baby's behavior if the baby heard it, because the baby cannot say so. The baby cannot say, yes, I did, no, I didn't. The baby cannot press a button like a grown-up can. So you have this one step removed. And the baby's performance, or rather the performance of the baby plus the observer, can be plotted as a so-called psychometric function, which is just an S-shaped ogive, and as sounds get louder, their scores get better from 0% heading up towards 100%. And you take the midpoint on that measurement curve and you say, that's the detection threshold. And those detection thresholds averaged over babies are what you see in this graph. So basically, it is assumed that the baby is detecting the sound if the observer can see them making some indication that they've detected the sound. And when averaged over babies, you get these kind of average thresholds here. It's like an adult's threshold curve just moved up. Okay, and you can do this with 3 and 4-year-olds, but you can actually teach them to press a button when they hear something or don't hear something, but they still don't do as well as adults. And that's an important point. That has important implications, which I'll get to briefly. So, how does an observer looking through a window, not knowing whether a sound was presented or not, tell from watching a baby whether the baby heard a sound? Very good question. And these are actual quotes from the primary paper that established a modern technique by Lindwender-Allshow in 1987, remains at the same university where Navita Teller devised this method for vision in the 1970s. That's the University of Washington. The observer looks for eye movements, eye widening and other changes in facial expression, actual turning of the head. Even though there's no speakers, the sound is going into one ear, maybe you'll turn its head. Changes in the level of activity of the baby. In one paper I read, they said that babies behaved superstitiously because one baby, when the sound was loud enough, would repeatedly kick the table. Another baby would hammer its fist when it heard the noise. Well, they call that superstitious behavior. And here's the important point. It is often the case that the observer outside the chamber cannot define the responses that are the basis for their judgments. They're working on intuition, essentially. Now, you ask how much exposure were they given to a particular infant? The answer is sometimes not much, and never a whole lot. They're not allowed to actually do a lot of practice trials. There's always a few practice trials so the observer can watch how an infant responds, and the infant can get used to the sound. Always, always practice trials, so that somebody at least knows what they're supposed to be doing in the experiments. Okay, in another paper it was said a watcher could use any available cues to support their judgments. Any available cues. Now, you're all more schooled in cybernetics than I am, I'm sure. I just came into this around 2009. So by now the concept of an observer and feedback and so on and so forth is nothing new to you. And some of you, I think, are already seeing some problems, I hope, with this approach. So let's look at this from a cybernetics point of view. Consider the roles of laboratory personnel. You've got an analyst who is actually the person who collects the data from what they're told by the observer outside the chamber. A lab analyst who determines the actual thresholds based on data, interprets the data, which is a form of stimulus, supplied by the hidden watcher, who is an interpreter or receptor of the behavior, which is a form of stimulus, of the infant holder duo, that is the infant and his mother, who are a receptor of the stimulus being given to the baby through the earphone. So you've got several steps going on here.
Lance?
Yes?
Excuse me, I may have missed it. Could you share with us, maybe again, the hypothesis of the researchers so we understand what their goal is?
Okay, the hypothesis of the researcher is that if the observer can tell correctly that the infant responded to a sound when it was presented, that the infant therefore heard the sound. If the observer correctly, let me rephrase that because I didn't phrase that properly. If the external observer responds correctly that a sound was presented when a sound was actually presented, because this is a go, no-go sound, no sound procedure. One interval, two choice procedure. And I apologize for failing to make that clear. If the external observer watching the baby can tell that a sound was presented and answers, a sound was presented on that interval, and a sound was presented on that interval, it is assumed that the baby heard the sound.
So the question is, does the baby hear it or not?
Yes.
Oh.
And this is for different frequency ranges, just that.
And you can use pure tones of signal frequencies, you can use white noise, shh, versus silence. It's even being done in tones in white noise. You can make the stimulus as complicated as you want. In fact, in early experiments, 5 different stimuli were used. Pure tones, noise, the first 4 or 5 tones of Pop Goes the Weasel, a woman's voice saying mama, 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 and a 5th thing which I've forgotten, but it was equally in name as the other stimuli. So, you know, that is the assumption. And based on what the observer tells the analyst then builds a psychometric function, which is assumed to define how well the baby is actually detecting or not detecting the stimuli, from a level of 0% climbing up to 100%, with a 75% recognition rate being considered a threshold for detection. And the thresholds are what are on those, basically audiograms. Okay, but it's typically a tone of a single frequency or a white noise of broadband. So it sounds like a hiss. Those are standard stimuli. Question?
And the purpose of doing this is to get an average, to see what average infants are able to respond to, or is it?
Yes, yes. The problem is that infants have remarkably short attention span, so typically the data will be averaged over several infants anyway.
Right, so you're not.
And the purpose is to find what that average curve of detectability is versus frequency. And the official reason for that, as stated on the grant applications, which brings the money in, is that someday this will lead to a diagnostic test to be used by doctors or nurses or whatever to see if young infants have perceptual problems. That's the rationalization. One day we'll be able to do this easily in a doctor's office with no special training. That's the underlying rationalization. And some have tried it in the clinic. And in fact, the visual test that I showed you right at the start, the woman holding the baby looking at a gray patch versus a gray thing, is called a teller acuity card test, and it is used in visual studies. Whether it actually means anything is a different matter altogether, but it's used in visual studies. It's used in clinical studies to diagnose whether babies have visual problems. Okay? So let's consider from second order cybernetics viewpoint what's going on. You got the stimulus represented by waves coming from a speaker. You have the infant, you have the watcher. In the early vision experiments, the watcher was literally looking through a peephole. In this case, the watcher is looking through a one-way pane of glass towards the interior of the soundproof chamber and focusing on the baby. And you have the analyst who actually takes the data from that watcher and builds a psychometric function which determines how well the baby has done. So the first impression, and this was the impression conveyed in the early literature, the observer is the baby. Baby hears or doesn't hear, baby sees or doesn't see. And then after a few years, the word observer-infant duo started appearing in the literature because somebody realized that the observer is not the baby. The observer is the baby and the person watching the baby. But it took a few years to get to that. A few years, it took 2 decades basically to get to that. And then when you think about it a little bit further, well, the watcher is gathering data, but all they're doing is pressing a button saying, yes, the baby heard or no, the baby didn't, in their opinion. And that's being given to an analyst who actually determines what the baby's detection threshold is based on the data. So you now have effectively an observer being the baby plus the watcher plus the lab analyst. So what's happening is that for all intents and purposes, the baby is being used as a blunt probe of the environment to give the entire laboratory some view of whether they can hear a sound or not hear a sound. For all intents and purposes, that's what's happening. So the question becomes, what ability is actually being inferred in these experiments? Once we realize that the observer is not simply an infant, we can recognize any infant improvement in the infant's perception as you change the stimulus, say, make a sound louder, make a visual stimulus easier to see. You can recognize alleged improvements in the infant's perception as changes in something other than the actual infant. Because what the experiments show is that as infants get older, and infants as young as 2 to 5 weeks have been tested in these experiments. So you can imagine the managerial difficulties of testing infants as young as 2 to 5 weeks. And the emphasis is to try and get infants tested from birth. So you can imagine the managerial problems, but the data allegedly shows that over the first, from birth to the first 4 months of life, their detection thresholds drop, that is, their hearing improves. There's a small problem there in that it is known from anatomical studies that the hearing apparatus, at least the peripheral hearing apparatus, is perfect before birth, and in fact may begin to decay before birth. This is one reason why you don't necessarily expose your baby to the ode to joy, at least not too loud, because the hearing apparatus starts to decay before birth. So how do you reconcile that? Babies should hear just as well as adults, if not better. In fact, they should hear better, especially at high frequencies and even low frequencies, with the fact that they seem to improve with time over the first few months, if not the first few years. Well, here's an answer. It may not be the infants that improves. It may be the person who is watching the inference that improves. In fact, there's very little data on this, but what little data there is, excuse me, shows that observers, when given in large groups and shown actual videos of a baby's response to stimuli, agree more on what the baby is doing over the first few months of life as the baby gets older. So what you're seeing is not improvement in the baby's actual capabilities, it's improvement in the observer's capability to infer something from the baby. And this I regard as one of the main second-order cybernetics conclusions. Now it is stunningly, let me finish, Tom. It is stunningly difficult to find any studies which have been done of how well people read babies' faces in response to stimuli. There's a huge literature on people reading emotions in babies' faces. That goes back to Paul Ekman of Berkeley, his students Harriet Oster and others. There's an extensive literature on how well people can read the emotions expressed by babies, which does get better over as the baby's face actually develops and as they actually develop emotions. So you would say, okay, so the observers in these experiments are trained in these Ekman methods of how to read faces. No evidence whatsoever that they're given any such training. So they can't tell the difference between an emotional response and actually hearing a stimulus. The observers cannot tell the difference. Tom, you had a question?
Just very quickly, is the literature explicit on how the observer of the baby, the person between the baby and the analyst, how that person is prepared or calibrated or selected, or is that a random person?
How is the observer of the baby prepared? The observer of the baby could be an undergraduate student participating for a course credit. Or they could be a member of the laboratory who's been there for years watching babies. In fact, one of the issues I'm going to get to is how many watchers is appropriate? If one watcher is not necessarily reliable, how many watchers should there be? That's a very good question. There's one laboratory, the Schneider Tree Hub Laboratory in Toronto, which used one person to judge babies for the better part of 3 years. On the other hand, there are theoretical models based on something called signal detection theory, which is too complex to go into here, which suggests that the optimum number of observers for an unbiased estimate is 5 to 7 simultaneous observers. On the other hand, you can have a different observer for each block of an experiment as you're training undergraduate students in your hearing research laboratory. So there is no fixed professional standard. No fixed professional standard.
I'm sure you're familiar with the story of Clever Hands, the counting horse.
It sounds familiar, but please tell me.
Well, you give a math problem to a horse and see how many times it stomps its foot. And they found that the owner of the horse was signaling the horse when to stop by raising its head or something like that. So I was thinking, well, maybe the mother is hearing the sound and sort of squeezing the baby.
No, one thing is that the mother has to wear headphones playing background music so that they cannot, in principle, hear the stimulus. The stimulus is typically going into an earphone right into the baby's ear anyway. So if the mother hears anything, it's very faint. But the other mothers are required to wear headphones, and the assistant in the booth is also required to wear headphones. And the observer simply presses a button. They do not know whether the sound is actually being presented. Their task is to say, yes, it has or hasn't, or no, it hasn't, based on the infant's response. Pilly.
That Clever Hands horse was actually a little bit more interesting than that, because they removed the trainer to make sure he wasn't giving him clues, and it turned out the horse was actually watching the audience to see when the audience breathed differently, when he was getting close to the right number of stomps. And so what that implies is that there are signals that we are not attending to that may be the relevant signals.
Yeah, I mean, this goes back to the fact that the observers literally can't say how they're making their decisions.
The thing in the baby's ear is a speaker or a microphone?
It's called an insert microphone. It's a little speaker that inserts into the baby's ear.
So it emits sounds or it detects sound?
No, it makes sounds.
Okay.
The sound is going directly into the baby's ear. Now, in some experiments, it's being played on a loudspeaker to the left and to the right for babies older than 6 months old, and the head turn is being examined. But again, the mother is wearing headphones. They can't tell when the sound is presented or which speaker it's coming through, and so on and so forth. So the idea is to try and make sure all the participants are blind, so to speak, to the stimulus except the infant. But nonetheless, the infant cannot give you a direct judgment. So the judgment is essentially secondhand. It's an inference. And this is where I, as someone trained in physics originally, have very serious issues with this whole approach, because all measurements are inferences, but not all inferences are measurements. Whereas these thresholds are always described by the persons doing them as measurements, as if they are precise. And there are further problems. I've got a lot of slides. I don't want to run over time. One of the things that is used to infer whether the infant heard something or not is, or saw something in the case of visual experiments, but also in auditory experiments, is if they suddenly attend and stare, the duration of the gaze. Because even if they hear something, it wakes them up and they stare. Widening of the eyes is one of the cues. Well, here's a small problem. If you look at how well babies gaze at actual visual targets, it's profoundly nonlinear over the first few months of life. So how are you using things like the widening of the eyes as a cue to whether they actually heard or, for that matter, saw something? It's a profoundly nonlinear effect. So let me get to my hypothesis. It's always good to present an alternative hypothesis. And my hypothesis is this. The threshold obtained in these studies of infants is not the threshold for detection of the stimulus, as proselytized in the literature for several decades. It's a threshold which has to be a higher threshold, and it's the threshold for distraction of the participant. That's what it is. It's a threshold for whether or not you can distract the infant participant, not whether the participant actually heard anything or not. And one of the problems with these studies is that there's a profound built-in confirmation bias in several ways. First, the observer has the right, in some experiments, to say, that wasn't clear, let's run it again. Thereby giving them the edge of saying, yes, the sound was presented. All the data is run through analysis of variance, and if the result was just not quite p less than 0.05, maybe that one infant wasn't really paying attention and we can just drop their data. These things happen. In fact, a student of, what department was he in? Sociology, a sociology doctoral student published a paper last year which raised a few hackles because he had embedded himself in 3 infant vision studies labs. And he found a profound confirmation bias. He found that in cases where more than one observer was used, sometimes 2, who were supposed to act independently, they actually spoke to each other and colluded about whether something had actually, the infant had actually seen something or not. And if the original hypothesis in the vision experiment wasn't quite satisfied by the data, they just changed the hypothesis and pretended that that's what they were looking for all along. And a number of unprofessional practices were revealed, followed by a string of, I think death threats is too strong a word, but tweets from various laboratory heads about, who was this punk and why was he publishing this sort of thing. But there are profound problems in that there is a very strong confirmation bias, as you find in psychology experiments. And this shows in the attrition rate of the infants, I shouldn't say attrition rate, the dropout rate of the infants. Some studies, they are required to say how many people started, how many people finished. It's not unusual at all to find 25 infants starting and final data based on 4. In one study, 250 started, and the final data set was based on 31, or something of that nature. And the reasons for the infants dropping out, or being told to drop out, which is the fact of the matter is, oh, they're too fussy, their attention span isn't long enough for the experiment, they spend too much time staring at the mother, they needed the diaper changed too often. You can just imagine problems with having an infant in the laboratory because they are inattentive. And that's why you have somebody in a soundproof booth waving little toys at them to get their attention. That is why you have this reward for the infant, the little toy monkey that claps its hands when the observer gets the correct answer, not necessarily the infant, which raises the question of just who is being operationally reinforced in this experiment. It's another matter altogether, and so on and so forth. But my hypothesis, based on what I've seen, is this. Based on this second order cybernetics look at who is the observer and what are they observing. That is, you're not measuring an absolute detection threshold. All the physiology says infants can hear perfectly well, better than we can. If they're not paying attention to a stimulus, they're just ignoring you. What's being found in these experiments is a distraction threshold. Just how loud or how bright does something have to be to actually distract the infant well enough that an observer who may have relatively little training can say, yes, infant saw that sine wave grating, yes, the infant heard that sound, and so on and so forth. Now, what is the use of the distraction threshold in clinical measurements, testing to see whether infants have hearing problems or not? As far as I can tell, 0. So you had some, tens of millions of dollars, and that's a minimum estimate, spent on finding what I think are distraction thresholds for vision or for hearing. And that's what my second order cybernetics analysis of this issue gets me to. Now, an issue raised by Robert, eye tracking. Can you substitute for the observer by doing things like eye tracking, actually watching the infant's eyes in the case of visual stimuli, or monitoring the turn of the infant's head towards one loudspeaker or the other in the case of auditory stimuli? Yes. You can track infants' eye movements. You can track their head movements. And that is, on its face, more objective. Now, you still have a human analyst in there, and you still have a fairly high dropout rate of babies that just can't do the task. But the fact is, there is a movement right now to do more of these electrophysiological measurements instead of using a subjective, intuitive guess about whether the baby actually saw something or whether the baby actually heard something. You can monitor the baby's actual physical responses in a more objective fashion. You still can't say for sure whether the baby can tell the difference between one sine wave pattern of stripes and another, or whether the baby actually heard the difference between a tone and a noise, or heard a tone at all. You still can't say for sure. The only way of knowing for sure is to actually do a physiological recording from the baby's neurons, which is not considered ethically appropriate, or have a subject who's old enough to indicate for themselves, which they've got to be at least 3 or 4 years old before they can do that. And even when you test 3 or 4 year olds, you get results somewhat similar to what you get from babies. Can anybody tell me why?
Can you ask the question again?
If you test persons 3 or 4 years old, you can prime them to respond themselves by pressing a button if they hear something. They still don't do a lot better than babies. Why? The answer's blatantly obvious. It's too easy a question. I'll answer it for you. Because 3 or 4 year olds are still kids and they're still very, very distractible. They have trouble concentrating. They have trouble focusing. So even if you make a sound loud enough that a 3 or 4 year old should easily hear it, they still don't get a score of 100% when they're indicating whether they heard it or not. In fact, 10% or so of the time, they're too distracted to respond. So you never get a score higher than 90%. And you see the same, even in the infant studies, you don't see a score better than 90%, even when something is so blatantly loud or blatantly bright that the subject has to be seeing it. So, future directions are just the things that Robert was talking about. Can we use tracking of the head movement using a lightweight frame put on the baby's head? Yes, we can. Can we track eye movements, again, using a lightweight frame put on the baby's head? Yes, we can. But unless the subject themselves can respond in these experiments, you will never have true objectivity. And I guess that's the point. Thank you. Sorry, Robert, Michael was faster.
So, listening to this, I'm reminded of a major, I think it's psychological scandal in Europe, where there was a professor named Stapel who basically cleaned up all of the data of his graduate students, and more than 50 people got PhDs based on data that the guy had cleaned up. And he was the head of psychology at a prominent Dutch university, and it caused a massive mess. My question for you is, how aware are the people doing these studies of the possibility that all they're measuring is distractions? And how much are they suppressing that self-awareness?
A very good question, thank you. I hope you all heard the question. First of all, the case Michael refers to, Diederik Stapels, the Dutch psychologist who in some cases didn't even clean up his students' data. He gave them falsified data that he'd made himself and said, oh, you can publish this in your PhD dissertation. So his students weren't even necessarily generating their own data. And that was a big, big scandal. And since he got fired and his papers got retracted, he tried to go on a speaking tour telling people how scientific fraud is committed. And at some point, even that didn't work. Apparently, this man was a great lover of all attention junkies. But the case is well familiar to me. And the question is, how many of these people realize they're only measuring a distraction threshold? I think that being thinking human beings who got doctorates somewhere along the way, I think all of the people involved must realize that what they're really measuring is just distraction thresholds. But once you get on that train of getting some grants and supporting some staff, and getting some grants and supporting some staff, one of the people I mentioned here who developed the current method, the one interval method, Lynn Werner Alshow, in 1987, invented the current method as her PhD dissertation, and still runs a laboratory of herself and 10 women supported doing entirely these experiments. But all they do is make the experiments more complicated. And I don't wish to particularly single her out because she's hardly the only one. So there are quite a few laboratories worldwide doing these infant studies in vision or in hearing. Are they honest with themselves? These are psychology professors. Don't get me started.
The follow-up question is, can we talk offline? We need to use this as an example when we're filing the grant on the second order science stuff.
Yeah, by all means. Robert, you have a question.
A comment and then a question, or maybe the question first. So have you been given the resistance to hearing this bad news, have you been able to publish this?
Have I been able to publish this? I have not even tried. I would not try to put this into the major journals, being Journal of the Acoustical Society of America and Hearing Research, in which both I've published in the past myself, doing standard hearing research with adults. The reason being that it would not get to publication. It would not, because it would be sent by the editor to precisely the people whose works I cite in the actual paper I handed in through the website, through the ASC website, the draft manuscript, who would, I have no doubt, sink the paper with extreme prejudice. There's not a lot I did my PhD in psychology. There is not a lot of tolerance for criticism in psychology. And this degree of criticism, zero tolerance.
Well, there is a field of critical psychology which is looking at these kinds of things, so there might be some possibilities there.
Okay, I mean, if there is a journal in psychology that would publish this, I don't know what it is. Let me put it this way. This would not get into a mainstream hearing research or auditory journal that I know of, because it would be considered too critical. It would be sent to precisely the people whose names I mentioned as using these things, and they would have every motivation to make sure it does not get published, because if it does, it's an embarrassment to them, and it'll affect their chances of getting grants. I mean, it's that simple. Now, and I've said this to engineering audiences about similar issues. This is the first time I've presented this presentation, but I've done presentations critical of, say, the way information theory is used to engineering audiences, and I've had engineers say, oh, have you published this in a psychology journal? And I've assured them, no, and it will never be published in a psychology journal because there's too much egg to be spread on too many faces, and those psychology editors will send it to precisely the people whose work I'm criticizing, and they'll shoot it down. And that's virtually guaranteed.
Then my comment was that there is a fundamental issue here which cannot be overcome. And that's something that was pointed out by Heinz von Forster, who pointed out that as a teacher, whenever I test a student, I don't actually know what's in the student's head. It's actually a test of the teacher. The teacher is testing himself. So now, I don't think he was against all research of this sort, but rather, and not against all testing of students, but he was simply pointing out to be a little careful and realizing there's this fundamental issue that what I know of the student's behavior is the minimum
Yeah.
that I can ascertain about what's in the student's head, not the
Oh, yeah.
maximum.
Yeah,
And
yeah.
that's basically what you're pointing out.
Yeah, I mean, as far as a publication goes, I know some of the players who are mentioned by name here. Now, I have no doubt whatsoever that they will not allow this to get published in any journal in which they publish. I don't mean slight doubt, I mean no doubt whatsoever. So I can say, that much I can say definitively, because I know some of the individuals whose faces I've shown on these slides and so on and so forth. Because I started out doing acoustics research in psychology before I got involved with cybernetics and more theory-oriented things. Tom?
First of all, thank you. It's always a pleasure. I would submit that any baby of any age is perfectly capable of focusing on whatever it is focusing on at any moment in time. But as the baby develops and becomes more social, it is more easily coerced to focus on what others want it to focus on. And that is neural development. I'm not an expert, my intuition tells me that's more a matter of neural development than the quality of the sensory apparatus, which you indicated are separate things. You referred to what physiologically, which you equated with objectively true, what physiologically the baby actually hears. I'm wondering whether that matters, because if these tests are conducted to develop clinical instruments to assess babies' developments later in the field, then the interest there is the babies acting in the social domain, which will be acted by very similar, which will be assessed or measured by very similar clues than those people are attending to. So the question is, does it really matter, or may the study, although flawed in its epistemology or worldview, still serve its purpose?
Well, it's ironic. I mean, you make a valid point, a number of valid points. It's ironic that the early experiments on vision by Fantz, in which the baby, where is it? Is just slid in a little trolley, and the observer looks at the people and sees what's actually sitting on what images on the baby's cornea. And this is from the early 60s, late 50s even, is in my mind more scientifically rigorous than the methods being used now, in which the observer guesses essentially whether a baby has heard a sound. And there's another question, another issue you raise. So the field has not necessarily become more rigorous. The people participating in the field think, because they're using forced choice methods where the observer has to say yes or no, baby did or did not hear something, which are subject to signal detection theory and other theoretical analysis, they think the field is more rigorous. I would argue that it's not, if anything less. And also there's the issue of using environmentally appropriate sounds. Steve, give me one more second.
No, take your time.
Using environmentally appropriate sounds, like the speaker saying mama, 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 or playing the first 5 bars of Pop Goes the Weasel or whatever, those things were used in the early 70s and then discontinued. So in that respect, the sounds being given like pure tones or hissing noises are actually less environmentally appropriate than what was being tried 4 decades ago. So the field has gone in a way which looks on paper as if they're doing experiments which are more scientifically rigorous, but which in actual fact may be less scientifically rigorous and less culturally appropriate for testing the child. We could talk about this for hours, but Candy also has a question. Pilly has a question.
It's actually not really a question. Maybe this is something that could be a concluding comment for now. If you want to publish it, I think no journal is going to accept it if you just criticize, because
Yes.
criticizing is backward, and what they really want is moving forward in the discipline. So I think it is publishable if you find a way to to express this as a contribution to the discipline. And you don't necessarily need to criticize everybody there, but you need to make a statement about the role of the observer in experimenting. And you can use this as one experiment, and you can even say that we have to just get used to the fact that the observers here to stay.
Oh, yeah, I mean, you can phrase it that way. I mean, in my view, any criticism which is accurate and sincere is not a negative result and is fair for publication. And I do present an alternative hypothesis, which people seek for publications. They say, okay, you said this is wrong, what's right, what's really going on? So there is this alternative hypothesis, which you will not find in the literature, to my knowledge. But again, it's not a question of fairness, it's a question of how the players involved are going to respond, which is also a cybernetics issue. And as I pointed out to Robert, I know the players involved. So the question is where to publish and when to publish, not necessarily what to say.
Yeah, maybe worth looking at the journals for measurement.
Yeah, I mean, there's a lot of issues that can be dealt with. Steve wants to talk at some point. Yes?
There are some relations between the experiments of Vygotsky in the early 20 and Piaget in the 30 with this kind of experiments about the perception of the infants.
Are you saying there were earlier experiments, or are there earlier experiments? There may very well have been experiments in the 20s and 30s on perception of infants. These things always have deeper roots than you would think from reading the literature, because the emphasis in the literature, especially in psychology literature, is actually on citing the most recent work in the field, not necessarily respecting what's come before. So it could be that studies of this kind have been done. But those are, those are harder to find from various viewpoints. So, I must yield the floor to the next speaker. I've already run past my time.